it's Caper Rants, and I'm about to rant to you guys about antiderivatives, except maybe it's not a rant, I don't know, we're in for a surprise. For all of you people who are in calculus, you already know what derivatives are, and maybe some of you think it's awesome, I'm on that boat, and maybe some of you think that it's not so awesome, and I'm going to make you think it's awesome. That's the goal for today. So I'm going to review the power rule, which is an awesome rule because it makes you feel extremely powerful, and that's also how I remember it so that I don't mix it up with the product rule. For example, if we have y equals 3x squared, and we're trying to find dy over dx, we can just go with 3x squared, we take the exponent, multiply by the front of the coefficient, and we subtract 1 from the exponent to get 6x. Again, we can try that. This would equal 6x. Notation, notation, notation. If we try that again, like for example, negative 4x to the negative 13, then you would bring down your negative 13, multiply by the 4, and then you would subtract 1 from the negative 13 to get 52x to the negative 14. And that would be your derivative of that. And that's a super quick, simple, easy way to do derivatives without that annoying function. Now, we're going to talk about the derivatives of basic functions. So, if you recall, the derivative of sine over x, or not over, wow, okay, sorry, sine of x equals cosine of x. Cosine of x equals the negative sine of x. And natural log of x equals 1 over x. And e to the x is my favorite because it equals e to the x. E to the x is so nice. Okay, so we just have to remember that. And everything will be so much simpler if we just know our derivatives of the basic functions. So now we get to the fun part, antiderivatives. Now first, I had a very hard time grasping this concept because I was like, man, I just got used to derivatives and now she wants me to reverse it. And then I figured out a quick, simple, easy way to do it. So now I'm going to teach it to you guys because I think everybody could use this. So antiderivatives. So antiderivatives are where you find your the derivative of the. Okay, I'm teaching derivatives, guys. Really? Really? We have interrupters.
Antiderivatives.
My dad.
Called.
Aren't they awesome? Wait, guys, say they're awesome. Say they're awesome.
That's also called the integral.
Okay, hey, spoilers! Okay. Alright, this notation means that you are taking all antiderivatives of f of x. This is your antiderivative sign. It's a super cool long S, and it's nice, and I wish my hair would look like that more often. You know, like this. Anyways, basically you're just taking the antiderivative of this function and all of them, because there's a family of derivatives, but since we don't want to write everything out because we're lazy, we just write plus c, and I'm going to get into that. So equals all antiderivatives of f of x. Okay, and so now we will start. Hello, Terry. Where were we? Basically, it's just taking derivatives in reverse. So it's where you got your derivative from. And you have an antiderivative family, but since we're so lazy and we just like to have one answer, you're just going to add plus c, which means your familia. So let's take an example. This is going to be super easy. What is the antiderivative of sine of x? Alright. So, maybe you guys are thinking, like me, I just thought this, it's going to be cos x. But there's always a way to check yourself, because you could take the derivative of cos x. What you're going to get? You're going to get negative sine of x, which does not match your first problem. So, that's wrong. Now, what can we do to just make that negative positive? Add a negative sign in front of this. Because think about it. If you take the derivative of negative cos x, you will get sine x. If you just think about that. Once again, if you took the derivative of this d over dx, you get sine x. You have those both. And that's your answer. Except wait, you have to add your plus c. Because otherwise you would get the thing wrong. Because that's not the only antiderivative of that, right? Yeah, cool. Awesome. Okay, so those are usually super easy. Now these usually are pretty simple if you've memorized your derivatives of basic functions, but there are harder examples. So 3x squared dx equals. Okay, so I just want you to pull this out real quick, if that's allowed. Is that legal in math? Yes. Yes. Is it? You can talk. It's fine.
Sure, yeah, you can talk about it.
All right. So pull this out. Remember when we used to do the power rule, we used to subtract from 1? Well, what do you think we're going to do when we do the opposite? We're going to add 1 instead. So you're going to add 1 here. And then what you're going to do with this is you're going to bring it down, all the way down here, to divide your coefficient by that. So you have 2 plus 1, or 3. And so what's going to happen is that's going to become x cubed. And another way to check it is d over dx, or d dx, x cubed equals, well, what happens when we take the derivative of this? We take the exponent down, multiply by the coefficient, and we subtract that by 1 to get 3x squared, which means that this all is true. I just proved myself, okay? And now you have x cubed plus c is your answer. All right, we can try this again just in case you don't believe me. Oh, we can try the one that I thought was going to be hard for you guys. 4x to the negative 13 dx. All right, so what are we going to do? We're going to take this out. And then we're going to do the opposite of what we usually do for power rules. So we're going to add 1, take this value, bring it down, divide the coefficient by it. So that would be negative 12. You can do math. And I know you guys can do math. All right. And negative 1/3 x
Raised to the power?
raised to the power of negative 12.
Okay.
Cool. And then how do we check this? So we do this again. D over dx. Negative 1/3 x to the negative 12. You're going to take your negative 12, multiply it by the negative 1 over 3. Or you're going to subtract 1 from your exponent, which gives you negative 4, or not negative 4, because if you can read my handwriting, which is usually impossible, that's a negative sign. And you're going to have 4x to the negative 13. That's your answer, which is what you had in the beginning, which means that this is almost your answer, because what do we have to add? Plus c.
This is very good.
Yeah, it's really
So
good.
now I'm going to have a more challenging example for you guys. So let's say x to the negative 1 dx. Now, think about it. Sometime. What would you do? Would you pull it out? Would you? Okay, I'm done. All right, so, yeah, you know what? Let's pull it out.
She's right here. Let me put you.
Okay,
Hang on.
so we're going to add plus 1 to get 0, and you bring it down to divide by 0. It's like, wait, you guys should be screaming right now because that's not a thing. That's really not a thing. I'm screaming. This is not okay. Because you cannot divide by 0. That is undefined. Bad juju. Stop. No, that's bad. No. That's the sign of the devil. Okay, so we're going to look at it again really closely. X to the negative 1. What can this also be written as? 1 over x. What does 1 over x equal in our derivatives of basic functions? That, yes, panning over the camera, right there, yes. It equals natural log of x. I really hope that's an absolute value. That's an absolute value of x because that's important too. It's not just parentheses x, it's absolute value of x. 1 over x is the derivative of natural log of x, which is why this is your antiderivative, because this is what you had in the first place in order to get this. All right, cool. So if you check that again, like I just said, natural log of x, dx of that, equals 1 over x, which equals x to the negative 1. And that is what you had. So you're going to put natural log of x plus c, because we're smart and we remember that there are a family of antiderivatives. I don't know, I try to make my own formulas for this until finally somebody came along and told me that this is what you could do, and just made my life so much easier, and it made me love derivatives even more. So that's my rant on antiderivatives. Maybe antiderivatives aren't so bad after all. Alright, thank you guys. Have a great day. Bye. Oh wait, no. What's my closing again? I haven't done this in a long time. Alright guys, okay, but just ranted. Alright, that's it. Done.